Well, good morning. A disclaimer, this is going to be somewhat of a philosophical talk. The first part is going to be about trying to understand what we mean with big data and what the implications are for medicine as a whole, as a society. And then I've tried to look for examples within psoriasis where you actually see emerging this new trend. And the Faroe Islands, for me as an epidemiologist, is what the Framingham study is for the cardiologist, is Faroe Islands for the dermatoepidemiologist. This has been kind of the golden standard. It's a beautiful place, and it's hard to get in and hard to get out. We have all experienced that the last few days. But that is a closed cohort, basically. And for an epidemiologist, that's beautiful. Very little flux. When I first talked about big data, and I had data sets which were larger than I would normally use, I was looking for people how to handle big data. And actually, I came across an astrophysicist. And he said, oh, you call this big data? This is just a laugh. And he explained to me that they have been working with big data for a long, long time. And this is what you get when the James Webb telescope is actually now using infrared, and you can actually see the creation of stars. And I will get back to this later on, because I think that's a nice kind of broad example of where we are going. Disclaimer, conflict of interest, yes, I like to take things apart, but I'm much less good in getting them back together. So I like to be critical. My kind of idea is I'm going to try to prove the opposite, and when I fail, I might accept the opposite. So I'm kind of critical in a way. Start with a definition of big data. There is no clear definition. This is what Wikipedia gives us. Well, it's big, okay? And that's, I think, important. That's running through the entire talk is data by itself is worthless. You need to extract value from data. And that's, I think, the main message of what I'm trying to get across today. But big data has some characteristics. It has a high volume, okay, quantity, but also quality. The last two V's are really about data quality. And big data is variable. You know, you see it in many different shapes and forms, and it just generates with immense speed. It just keeps on increasing rapidly, which is very much in contrast to Gunnar's work in the Faroe Islands, which was kind of a stable situation. This is a very dynamic field. And as we all know, data is exploding. There are many graphs on the internet just trying to show you this. And it goes exponentially, and it goes very, very fast, to an extent which I think is almost hard to kind of grasp. And the same is true for healthcare. We are generating so much data per patient, and that on a longitudinal scale. And these data sets are very interesting for the AI or tech companies, because we have data and we have added value, annotations to the data, so we know what each data point actually means. But for the outsider, of course, it's a big mess. So what I'm trying to show you with this graph is, like I said, data by itself is out there. It's all over the place, but has very, very little value. The real challenge is how do I get from data to expertise? And it needs a transformation. And it needs people, even if you think about the large language model right now, there are thousands and hundreds of thousands of people annotating things. Every time you are asked to click, when you want to send a mail from PubMed, for example, you have to click the bridges or the motorcycle or the traffic lights. You're basically helping AI. You're basically helping annotating data, understanding data. So there are thousands of people, night jobs, in-between jobs, who are trying to make sense of the data out there. And then the next level is that it becomes information, and ideally it becomes knowledge. So in the bottom part, the data part, it's really unstructured, it's simple, it's rough, it's dirty. And you try to bring that data up to a level where it is sophisticated, it has quality and quantity all in the same time. Of all the papers I've read about big data, and I don't consider myself an expert, by the way, of big data, I still think that this is really a very nice paper in the New England. It's already a few years old, but it really gives us an idea as a clinician where we're heading. And it basically shows that the way we have been trained, it's really up there. algorithms. If we think back about, how we were trained as residents, you start with the papule, is it red or is it non-red, and then you just work your way down through the algorithm. This is how we've been trained. It's craftsmanship. And we are collecting lots of images as a dermatologist and try to make sense of it. Machine learning is going to change the world, I think, because it's just going to help us process more information than we are capable to understand. And that will eventually, I think, really kick in prognostic work. And I will show you some examples in psoriasis or psoriatic arthritis. And we already see it right now that the specialisms that are involved with images, like us, but radiologists are really far ahead of us, are going to, feel the influence first. The advantage for a radiologist is that it's relatively structured. You put someone in a CT, but even a CT, so AI is able to pick out that certain CTs are from different hospitals or different, etc. So even if we think it's structured, for AI, it's not even that structured. But I think about clinical pictures in medicine is, of course, a mess. So we used to approach science with an idea that less is more. If you would ask a mathematician what is the best solution, it is the simplest solution. And I think that has been kind of the idea of how we have been looking at science, or at least I was, just try to simplify it as much as possible. But we're now entering a phase which is going to be, at least for me, it's too complex. So it becomes more intuitive, and you have to rely more on big data. So when I started as an epidemiologist, we were thinking about classifications. We had the lumpers and the splitters in dermatology. People classifying diseases. We just heard different names for atopic dermatitis. We were very good at that. And then epidemiology came in and we started using regression models. Okay, it took a while for us to adjust, but I think we kind of got the idea behind it. And now we're moving up to the left into machine learning, there's a price we pay for handling that data, and it is going to be less and less explainable. We are able to process more data, but we're going to understand a little bit less. So we pay a price for this. And this is how I think about it. It's kind of an information stress. When you just generate so much data, we have been trained that more data, more information is helping us to get a clearer answer. But the human mind, has a certain capacity. I think the rapid access memory for a normal mind is about 7 digits, which is a big laugh. And the entire human brain only can contain, was it 1 million gigabytes or something, which in the current data world is 0, right? So we thought that adding more information will actually help us. And I think we've been right for a long, long time. But there is a tipping point where more information becomes just more confusing and less understandable. And I hope, honestly, that machine learning will help us kind of take that hurdle and obstacle. But of course, you can overfit. It might not be reality. So there are already warning signs out there in the literature showing that, you have to be very careful. It's not the ideal answer. You have to remain critical. But I think it will change about how we look at science, how we will look at data, how we look at our own performances and at our own patients. And then thinking about the trends we've been seeing. We've talked about Gunnar's work, and he was in the epidemiology, so he was kind of more in the upper part. He did a tremendous job in creating a patient cohort. We all have done case series. Probably the first paper you ever wrote was about 1 patient or 2 patients, or maybe 10, but that's where we've all started. And in epidemiology, we've been moving. More data, more routinely collected data, bigger registries, just basically extending the number of patients. On the lower bottom, which is really not my field of expertise, but I remember it took days or months for people to collect data. They were trying ELISA blots, PCRs, whatever, and it took months for them to create data. And now again, you have this array and you put the tissue in and it creates more data than you can handle, and it takes years to try to understand what actually came out of it. And then if you think about a multiplier, and I think that's where we actually are going and already heading, is that if we now cross-link routinely collected data with omics data, or we use multiple omics approaches, or we think about linkage studies, including microbiome analysis, claims data, medical record history, etc. It becomes data integration. And no, I don't know about you, I mean, that's really, really, really difficult. It's even difficult to find people who understand what we want them to do. So this is your ideal world. It would be an engine which you basically feed data, feed questions, and that will translate back to the clinics. So I've tried to come up with some examples in psoriasis, trying to think about this. And I think we've all read at least grant proposals about multi-omics, multi-level data. System biology is maybe an old term, but it is basically the same thing. But then, if you start thinking about it, and this is of course what we do, we have been thinking about many of these problems or associations in a very unidimensional level. I now have genetic data and I have patients and they go from A to B. But we all know that there is lifestyle involved, that there is epigenetics, metabolomics, you know, many more dimensions to it. And I think that's the complexity, and that's hopefully where big data will kick in and AI will help us, or new data sciences. But then if you actually open PubMed and try to think about, okay, where are the papers using multi-omics approaches, there aren't that many for now. So I think this is something we'll see in the near future, I guess. But it is a big obstacle. It's a big hurdle to take. This is some work far away from my expertise. So I just want to show you that there is work being done where they looked at, well, single cells. Just think about it. You know, if you start looking at single cells, what does that mean for your data and the amount of data you create? If you give that a spatial component, so in time and in space, it's going to add more dimensions to the data. So it's hugely challenging. Here is another example where they've tried to just look at genomics data and try to see whether they can create clusters of psoriasis severity, which you see on the bottom, or patients that are likely to develop, based on skin tissue, to develop arthritis components. So it's kind of the multidimensional approach. Same here. I thought, actually, honestly, when I started looking, I thought we were further with the microbiome, but it has been a big promise. But if you think about where did it actually lead us so far, not that far yet. And it has to do something with the complexity of the interplay between the microbiome and its host, or our patients. This is a very nice overview, which goes from the microbiome on one side, but tries to explain what the levels are on a protein, or what is actually happening on a protein level. Instead of just saying, which is kind of the more direct approach, is we see a certain microbiome with psoriasis compared to controls or compared to atopic dermatitis. The interplay is going to be more and more important. This is more my field of expertise, or feel a little bit more comfortable talking about this. And these are just a few examples of how big data has started in dermatology and how that has been improving our knowledge and our science. I mean, I think bad beer is probably a very, very nice example of how we should have started with patient registries in the first place, but it's really paying off. Well, the Scandinavian national databases, beautiful. I mean, I've been jealous on our Denmark, Danish, and Scandinavian colleagues with the data available. But you also see that these biobanks, for example, in Denmark, now start to create patient biobanks to kind of have the interplay. So we have data sets on a general population level, but they just don't provide enough information, not enough granularity in the data, that they kind of look for the Danish skin cohort or the Danish psoriasis cohort of clinical patients and try to merge them together, get them together to increase our understanding. Commercial cohort, we're in the Faroe Islands, so I basically should have put up their decode. The Icelandic initiative has created so much insight. Again, an isolated island, hard to get in and out, ideal situation. Decode is now commercial. It's the same with 23andMe. Huge data sets, huge information. Health services, I saw Aaron there. He was one of the first trying to use claims data, so insurance data sets, and really try to kind of create more knowledge out of that. And the UK Biobank, another thing I'm jealous of, is a beautiful initiative, shows you how rich the data can be if we work together, and then you create really, really big data sets. So a few examples. I'm going to skip this for time. This is in the UK Biobank. Incident psoriasis. Very interesting to look at, who was really at risk of developing psoriasis. It's not just genetics. And here they've investigated almost like a gene-environment interaction study and looked at lifestyle as well. And it doesn't surprise, of course, that if you have a high genetic risk and you have a poor lifestyle, you're at the highest risk of developing psoriasis. So maybe the fish and lamb diet wasn't that bad after all, 50 years ago. Same thing here. This is in the Danish study. Looked at, can we predict who is actually getting psoriasis? But then if you look at the number of variables, and this is about psoriasis severity, it's still very straightforward. It's about age. Have you seen a dermatologist? Have you used biological drugs? These are kind of the clinical things that are so kind of simple and straightforward. So it's a nice attempt, but the feeling is there's no genetics in there, there's no lifestyle in there, there's much more information we're missing. This is from Asia. They used claims data to see who is actually going to develop psoriatic arthritis. Again, very simple, very rough data. So we're in the pyramid, we're basically at the information level. So we need to kind of expand. This is a little bit deeper. This is a study where they actually looked at, can we predict who will get psoriatic arthritis in our psoriasis cohorts versus what will be the progression if you do get arthritis components. The biggest bar provides the most information, and interestingly enough, that's age. So how simple can it get? But age is a proxy for many things. Age is a proxy for your lifestyle. Age is a proxy for your genetic survival. So age represents much more than just a figure. But you can see how we are merging data sets together to try to understand. Same thing here, trying to predict who is going to respond to all these expensive drugs we're using. But at the end of the day, you see that the area under the curve of this normogram is 0.6, which is close to flipping a coin. So we're not there yet. This is interesting data, and I don't want to insult anybody because all of these authors are in the room. So that, I respect their work. I don't want to pick a fight with anybody, but just to kind of, we're kind of tipping our toe into the water, but I think we haven't really fully dived in yet. What I liked here is that they actually used RCT data from commercial trials in a different way. Instead of just only trying to get the drug in and register it, etc., they've tried to use it in different ways. And this study actually shows, are there different clusters of psoriatic arthritis, and then who is most likely to respond to the drug? And here you can see the male overweighted with psoriasis is most likely to respond, this cluster of patients is most likely to respond to Gezelkumab, I thought it was, yeah. And this is something I'm really a big fan of, and this is about linking cohorts, and it is about giving you the opportunity to kind of zoom in and zoom out in your research question. So like the Danish created their general population data sets, and adjacent to it, they created a patient cohort. This is the UK Biobank, and it is big. It's like 500,000 people, so it sounds like heaven for an epidemiologist, but we lose information. It's self-reported diagnosis. There are many pitfalls for psoriasis in there, for example, but also for your outcome like depression or anxiety. So then they kind of, adjacent to that data set, they kind of look at primary care data. But then, and that's at the bottom, you lose about half of your patients. So from 500,000, you go to 230,000 people. And then if you have more detailed information, you use the mental survey, and then all of a sudden you have left 70,000 people. So where you started with a lot of people, but you want to gain more information, the numbers go down. these are the results. I think this is something, hopefully Axel is going to talk about as well, but Mendelian randomization is a very nice way in thinking about how to use big data and circumvent some of the causality issues we have in dermatoepidemiology. And I think we will see much more of this, or we're already seeing much more of this in the last few years. This study looked at alcohol and smoking. Alcohol was okay, not that clear of an association. Some suggestion that smoking was in there. It is time. Skip this, but I thought it was interesting. GCI article about apremilast trying to, it lowers the alcohol consumption in our patients, which I thought was fascinating. And this is going to be talked about by one of the next speakers, so I'm going to skip that. And we have a bright future, but lots of uncertainty in there. We have to try to kind of think about a way of how to deal with that uncertainty. And this is my last slide I will end with, is it might not be worthwhile investing in bigger cohorts or bigger satellite systems or more of the same, but I think the future is really in linking it together, bringing it together, getting more detailed information. Thank you.
Thank you. Really interesting. Just one short burning question. Okay, then it's only me who there. I have a question. Just a sort. I get a little bit afraid of all this data. How do we manage to handle it just as a normal dermatologist?
Well, there was the last slide. And actually, I gave this presentation about half a year ago, and then I said, science becomes like a religion or an art. I took out the religion because I thought it might be too sensitive. But it's very true. I mean, and when I said early on, it's becoming more intuitive. So I think for us as clinicians, or most of us, you have to trust your bioinformaticians, what they are doing. And we have to kind of think about a way how we cooperate and bring that knowledge together. But I feel very uncertain. I now have PhD students which I have absolutely no idea what they're doing. And the only thing I can read and look at their analysis and their outcomes and think like, does it make sense? Or is something really fishy going on? And then, so even in my direct science, we take a different position in where we can, I think, and they are crucial. Without us, they are lost. Then there's so much data, there's no relevance, there's no expertise. So we need to work out together. But we can't, I mean, I think I'm entering a level where it's too complex for me. Not very reassuring,
So